Hello, this is chemistry topic 5, the final topic I've got so far, on bonding and structure, as you can see here. Also, I did some questions on the back quite a while ago and just stuck them on there because I thought, that would be cool. So, bonding and structure. So, there are lots of different types of bonding. One type of bonding is ionic bonding, which is between a metal and a non-metal. Ionic compounds are in giant lattice structures and the positive and negative ions in it attract. They also have strong electrostatic forces of attraction. So in this method of bonding, atoms become ions, which means they gain or lose electrons to make a full outer shell, as we can see by this. So lithium, the metal, has an electron outer shell of 1, and fluorine has an electron outer shell of 7. So fluorine needs 1 more, and lithium needs 1 less. So lithium gains a +1 charge by losing 1 electron, and fluorine gains a -1 charge by gaining 1 electron. This thing here is Ionic formula, so basically by the changes in charge, you can tell the changes in the amount. So because the I has a minus, which means it's only lost 1, that means there must be 2 of the I to make the magnesium lose 2, because it's gained 2 charge, so that's gained 1. So the iodine has, I think that's what it's called, has gained 1 electron, but there must be 2 of them to match up with the 2 on that side. That's basically what this shows. This makes magnesium iodide. So, the next type of bonding is covalent bonding, which is only between non-metals. So, a simple covalent bond, examples of which being water, H2O, and CO2, which is carbon dioxide, are non-soluble. They have a low melting and boiling point, and they are small molecules. However, giant covalent structures are giant structures, which makes sense. They have a high melting and boiling point. Examples include diamond and graphite. So basically, covalent bonding doesn't involve any ions, and it's only between non-metals. Electrons are shared between the non-metals until they both have a full outer shell. So if you see this, hydrogen was 1 and chlorine was 7. So now it turns to hydrogen chloride, and the H now has 2 and the Cl now has 8, which makes them both form full outer shells, whilst staying as one thing instead of ions. Our next type of bonding is metallic bonding, which takes place between, 2 metals. So what are metals? Metals are giant structures of atoms with delocalized electrons, which means they can carry a current, which means an electric charge. Metal atoms are arranged in a regular pattern with positive metal ions, where there is a strong electrostatic attraction between them, which is a metallic bond. The thing that makes metals malleable is the fact that layers of atoms slide over each other. However, an alloy, which is a mixture of metals, means that atoms can no longer slide over each other as they have an irregular pattern. It makes it stronger. So basically, when metals are bonded together, they form strong electrostatic attraction between each other. So these delocalized electrons that carry current are often known as a sea of delocalized electrons. If you're asked to describe the structure of a metal and metallic bonding, you may want to say that there is positive metal ions surrounded by or in a sea of delocalized electrons. So this is pretty basic, but we'll cover it anyway. So solid, liquid, gas. So as you can see, gas particles are further apart, liquid closer together, and solid closer together still. So solid turning to liquid is melting, liquid turning to gas is boiling/evaporating, condensing gas to liquid, liquid to solid is freezing. So solids are difficult to squash, they don't flow, they have a fixed shape, they're bonded together, and they have a high density. And sort of all these things decrease. So the density goes down, easiness to squash goes up. So they all change throughout the thing, not bonded together. No fixed shape, flow. So they all change throughout the forms. So the next bit we're moving on to is monomers and polymers. So monomers are alkenes, which we covered before, but not that they're monomers though. They combine with other monomers to make a polymer. So a polymer is basically a large molecule of many monomers joined together. So these are two different monomers. This is them turned into a polymer. So it's got the same amount of H's, the same amount of C's. The only difference is the fact that the C's can join together. And how this happens is, you can see the double bond in between them. That splits. So it turned into a lot more bonds. So where were we? Examples of giant covalent structures. So this is a structure of diamond, not very shiny here, and the structure of graphite, pencil. Diamond, 4 carbon atoms put together on every part, which makes it stronger there is no layers. There is also no charge in it. However, graphite, there are 3 electrons which conduct electricity, and there are only 3 carbons together. There are also weak forces in between these layers, which means that just like in metals, layers can slide over each other. An important thing to know is that these are all carbon atoms, and that these bonds are covalent bonds, and these bonds, just on the individual layers, are covalent bonds. So that's bonding and structure. Simple, ionic, metallic. The things I always forget is metallic is with metals, obviously. Covalent is only between non-metals, and ionic is between a metal and a non-metal. I sometimes get mixed up between these, so I just wanted to clarify that. That was bonding and structure. Okay, goodbye. No, seriously, guys.